Okay, so the first part was just all kind of the warm-up. Now we're going to start to do some very general stuff and derive the formula for the circle itself. So suppose a circle drawn in a coordinate plane has center HK. All right, so this is just some random center HK. It can be like any positive whole numbers if you want to make it easy on yourself. All right, and it has a radius R. All right, so centered at HK has a radius R, and then it goes to some random point xy. So these are just random points that we can imagine, random lengths, so on and so forth. So right now we're going to write an expression that represents the distance between center HK and any point xy that lies on the circle. In other words, we're going to find an expression for the length of r. So we've been keeping it pretty simple using the Pythagorean theorem shortcut, but this is going to be more distance formula like. All right. So we have r, that's the slanted length here. This right here, we're going to call this x minus h. All right. We're using x, we're using h. The horizontal length is the difference between those two, just like how we do x sub 1 minus x sub 2. I'll even write that. In the distance formula, we have x sub 1 minus x sub 2 squared. All right, that's a little foreshadowing. All right, the square, technically we don't need that quite yet. Furthermore, we're going to have y minus k right here. And again, we're using that to get that. It's the horizontal length is just the difference of the y values. Thinking of the distance formula, it's like this portion right here that we're finally going to get to. All right. And then this is going to be r squared. So r squared is going to equal, instead of saying x sub 1 minus x sub 2, we're going to say x minus h squared plus y minus y sub 2 squared. All right. Now, oops, sorry, I went full distance formula right there. I meant to write y minus k squared. All right. And then we could take the square root of both sides, and this is how you would calculate the radius with a circle with any center and any point on the circumference. All right, this is a very general formula to find radius. All right, it's like the foolproof way. It's always going to work. Are you expected to derive this or completely understand where it comes from? No, but you need to have it memorized. You need to know how to use it. And in fact, why I wrote this down is so we can write the standard form of equation of a circle. It's literally just this. It's very distance formula-esque. All right. That's it right there. Bada bing, bada boom. R squared equals x minus h squared plus y minus k squared. All right, R is the radius. HK, why do we use HK? I have no clue, but that's the center point. And then x and y, they're actually just our variables. Just think of our, like y equals mx plus b, all those equations we have. X and y are just our variables. All right, so that's it. You have to know this. You have to be able to use this. Using this, we can identify the center of the circle, determine the radius, graph things, so on and so forth. This is just the standard form. All right, there's different forms, but we have standard form. All right, so this is the most basic one right here. What is the center of this equation? So x squared plus y squared equals 25. Remember, this is the standard form. So looking at this, we can say, well, hold up, people. We're not subtracting anything from x. So the center, HK, the h is going to be 0. And what about y? Well, we're not subtracting anything either. So the center is actually just 0, 0. It's the origin. All right. Then remember, it's r squared. It's r squared. So it's really just 5 squared. So then that means the radius is just 5. So essentially you take the square root of whatever the like 25, or in other cases you'll see you taking the square root and that's how you determine the radius. It's just 5. All right, oh, and that's what's radius. Oops, we got super excited and answered the whole question right away. All right, looking at this problem right here, what is the center of this circle? All right, so when we extract it, when we extract the center, it's a good idea to kind of think about change the sign, all right? Change sign. What do I mean by that? Well, it's x minus h. So since it's x minus 6, that means the center, hk, that means it's actually positive 6 being plugged into the equation. It's positive 6, because you plug in positive 6 for h, you're going to get x minus 6, which is exactly what we wanted. Similarly, over here, it's y plus 4, so that means we plugged in a negative 4 for k, all right, because we have to think about changing the sign. All right, so that's the center. And then what's the radius? Since it's 16, r squared equals 16, so r is just 4. All right, again, almost think about taking the square root of whatever it equals. All right, and then this right here, we're going to write the standard equation of a circle whose center is negative 5, 0, and the radius 6. And again, I try to model good habits. Notice how each and every time I'm writing the standard form for equation of a circle, it's similar to the distance formula, still something new, and it's just going to help us build it into our muscle memory as I plug in things, understand how it works, how it all combines together. And notice how typically too, I don't even skip steps. I try to be as thorough as possible. So I'm going to have x minus negative 5 squared plus y minus 0 squared equals 6 squared. And then it's just simplification. All right, what do I mean by that? Well, this minus a negative, minus 0, and the 6 squared can all be simplified, so I can get x plus 5 squared plus y squared, because it's redundant to write minus 0. Technically, that always exists, and it equals 36. All right, and then that's it. That's standard form of the equation of a circle. And in fact, we're going to practice graphing and doing some other things on this last page.